In this problem, we have to solve the equation 3e raised to the x plus 1 equals 15. And we need to round the answer to 4 decimal places. This is a big hint that you're going to need your calculator. So what type of equation do I have here? I have my variables in the exponent. So this is an exponential equation. The simplest type of exponential equations are when you can make the bases the same on both sides. Well, I have an e raised to the x plus 1 over here, no e over here, so that doesn't look possible. So this looks like the type where you cannot make the bases the same. So we're going to have to use logarithms to solve this problem. There are 2 different ways of solving this problem. I'm going to show you both methods, and you can pick the one you like the most. Method 1 is when you isolate the exponential expression. Then you take logarithms of both sides of the equation, and then you simplify using one of the properties of logarithms and solve the resulting equation. So if I look at my original equation, is my exponential expression isolated? No, I've got a 3 in the way. So let me write out my equation. So the first thing I've got to do is divide both sides by 3. So I'm going to get e raised to the x plus 1 equals 15 divided by 3 is 5. So step 1 is complete. Next, we need to take logarithms of both sides of the equation. Well, I could take log to the base 10, but since I already have an e in this problem, I think I need to take log to the base e of both sides, and that is the natural logarithm. So I'm going to have the natural logarithm of e raised to the x plus 1 equals the natural logarithm of 5. Now we've done step 2. Step 3 is I'm going to need one of the properties of logarithms to simplify this side. Well, there is an inverse property of logarithms that says log to the base b of b raised to the x power is x. As long as these 2 bases are the same, they undo each other, and I land up with x. Well, remember, the natural log of e raised to the x plus 1 really is, if I write it in longhand, log to the base e of e raised to the x plus 1. Are these 2 bases the same? Yes. So I'm just going to get x plus 1. So my left-hand side gives me x plus 1 equals the natural log of 5. So subtract 1 from both sides. X equals the natural log of 5 minus 1. So that is our exact answer. If you're ever asked for the exact solution, that is it. And now we need to put our expression into a graphing calculator. So now I need to just find the natural log of 5 and subtract 1 from the answer. So let me go find my calculator. This is a TI-84 Plus. Here's the keyboard, here's the screen. So I needed the natural log. So hit ln key. Notice it's very important. It puts in a parentheses. So then you have to hit 5, the argument of the log, and then you must close the parentheses after the argument, and then you hit minus 1. Enter. And that is going to be our answer. What I want to show you is what a lot of students do is they hit natural log of 5 and just subtract 1. Does that give us the same answer? No, because the calculator closes the parentheses here, so it takes the natural log of 5 minus 1, which is 4. So you get a totally different answer. Our answer is the one at the top. So here is a screenshot of our answers. Remember, this one was totally wrong. You must have the parentheses around your argument. So this is our answer here. We have to round to 4 decimal places. 1, 2, 3, 4. What's the 3 going to do to this 4? Nothing. So our approximate answer is x equals 0.6094. And that is the answer rounded to 4 decimal places. I quickly wanted to show you the second method for solving this problem. It required you to isolate the exponential expression, so this is exactly what I did last time. So I just copied it from the last page. And now in step B, instead of taking logs of both sides, it says use the definition of logarithms to convert to logarithmic form. That says this is the exponential expression, this is the logarithmic expression. So what is the logarithmic expression that is equivalent to this? Well, it's just log to the base e of 5 equals x plus 1. But now, do we ever write log to the base e? No, we write that the natural log of 5 equals x plus 1. And then what is x? All I have to do is subtract 1 from both sides. And is that the same as I got by the other method? Yes. So does it matter which method you use? No, they both give you the same answer.